So now we're looking at conservation of momentum. It's not the same as impulse. Impulse is change in momentum. Conservation of momentum says that if one object loses momentum, the other one gains momentum. It says the changes, the impulses, will cancel each other out. But we don't solve it using force times time. We don't solve it using impulse. What we say instead, we notice there are two objects, two masses. That's one of your hints. We notice there's a collision or an explosion. There's a jeune. This is a job for conservation of momentum. So we have a curling stone. I think I said to you curling, much like my little hovercraft there, which may be used for human curling next year. We'll see if I can figure out a way to do that. They're great examples of collisions, except all curling rocks have the same mass. I said to my class yesterday, actually, it would be interesting if they, for example, had 3 different mass rocks for curling, and you could pick, depending on which shot you wanted, depending on what you wanted to do. Not only would you then be aiming, but you could dramatically control how much momentum you wanted to pass on to the other objects. That'd actually be kind of interesting. So I will give you curling questions, Brian, except I'm going to make the masses different. Otherwise, the M's will just cancel and be boring. Brian, in example 3, is there a collision? How do you know? Because okay. And they're wanting me to find the velocity. Typically, I'll ask for the final velocity. I could ask for the initial velocity. I can get any velocity I need to by itself, which is why the only equation that I've given you for this concept is this one. This is a job for conservation of momentum. This is the one that I put on your formula sheet. What does that mean? What does that funky sigma symbol an abbreviation for? Total. The sum of, if you really want to be fussy, because it's not just total, it's add up the total, but the total initial momentum has to equal the total final momentum. You know I like to abbreviate, Oliver. That's as short as I can write it. I think when we did the notes, I wrote it out once in the box, and then here's the various ways. Then the rest I adapted to the question. Brian, is there more than one mass? Mass A, mass B. If you do that, I'll figure it out. You can write MA equals 22, MB equals 16. I'll figure it out, though, if you just do that. Brian, do you see directions in this question? That's a warning for me that I better let one way be positive and one way be negative. Or if I see the word rebounds or bounces off or any words along those lines which imply a change in direction. So we're going to let one way be positive, one way be negative. What do you want to let be positive? Okay, so I'm going to go like this. Plus sign there, and a plus sign in front of the 3.2, minus sign above the word west, minus sign there. The second stone moves off positive, that. I guess we have a bit of a problem here. Somehow the second stone goes through the first stone. I meant to change this question, and I clearly forgot to. Because the first stone is moving which way? East. The second stone is moving which way? West. And after the collision, oh no, wait a minute, it's possible the first stone could have lost the collision and also end up going west even faster than the second stone. Ah, that works too. You can hit like that. Think football player tackling a smaller player. You've seen it happen during games. Yeah, okay, I'm good with that. So before the collision, Brian, what's moving? Mass A, mass B, both or neither? Stuck together or separate before the collision? So I'm going to have this. You know what? Let's see if we can be bold and shave off one step. Momentum is what times what? So instead of writing PA initial plus PB, can I go mass A, velocity A initial? Okay, let's try that. So it's going to be mass A, velocity A initial plus mass B, velocity B initial. Yeah? Wham! They collide. I wish she wasn't wearing headphones. That would have been so much more effective, but that's okay. After the collision, mass A, mass B, both or neither. Definitely mass B, the second stone. And what's it asking me to find? Of mass. If the answer was 0, that's a stupid question. Mass A, mass B, both or neither. Stuck together or separate? Stuck together would be a dumb question, because then the answer would be 2.4 meters per second east, because they gave it to me separate. Yes? So we're going to have mass A, V, A final plus mass B, V, B final. Why am I putting the vector signs above the V? To remind myself, Tristan, be careful with direction now. What am I trying to find, Bri? 4? Yeah. How to get that by itself? I guess I'm going to move this over. How? And then how would I move the MA over? Could we do that one step? I'm in. So you're telling me the left-hand side is just going to drop down like a domino. I'm going to minus the mass of B, velocity of B final. I'm going to divide by mass A. Folks, is Brian right? Are you going to memorize this equation? No, please don't. Because all I need to do is ask for something different or have them traveling in different directions. Or what you need to know is this. What you also need to know is the importance of showing up on time. Let me just pause the video so I can yell at a student. Hey, now we're at the plug and chug stage, Bri. Well, I've scrolled down. What was the mass of A? This is why we labeled things, so we don't have to think. 22. Velocity A initial? 3.2. Plus mass of B? That took a while. Velocity of B initial? Thank you. Minus 16. Velocity B final. Positive or negative? Are you positive? Mr. Divided by 22. What do you get here? Yeah. Quickly, bunny. Sorry? 0.29? Positive or negative? See, I've made up a bad question here. I need to fix the numbers because somehow, positive, what direction? East, yes. Because somehow I have rock A coming in, rock B coming in, wham, they collide, and I guess rock B kept going through rock A. I need to fix these numbers a little bit. I was making up some nonsense numbers. The collision doesn't make sense to me. Now, what would make sense is if instead of curling rocks, maybe if one of these was a bullet, then the bullet would have slowed down but made it through its target. Okay, that's feasible. Anyways, is this collision elastic or inelastic? Sorry? Elastic? How can you remember? What are elastics made out of? Rubber? Bounce. Oh, bounces off each other. It is elastic. So I had already said you could try number 1, 2, 3, and 4. I'm going to give you a whole bunch of these. 5, 6, 7, 8, 9, yeah. 10 is good. I'm going to assign all of these, but I think I'm going to sort of pause here. Except, can you do me a favor and can you go back to lesson 4 and let's look at Calvin and Hobbes. Now, if you got this, great. But I've helped about 7 or 8 students during my flex blocks or after school with this. So let's walk through it. I'm going to walk through number 5, and that will still let you try number 6. Okay? And what I'm going to do is cheat a little bit. I'm going to go to a blank page, and I think if I open up the notes... What lesson was that? Lesson 4? think I can go capture. Make it a little smaller. All right. So in this question here, Calvin is running in the same direction. You know what? This is what happens if you've ever chased somebody down from behind. Hobbes, the pet tiger, is chasing Calvin down from behind, but they're going in the same direction. Okay. Cool. What does A want me to find? Is there a collision?
Yeah.
Conservation of momentum. Okay. So I would start out by saying the total momentum initial equals the total momentum final. I think I'll use H for Hobbes and C for Calvin. You can use A and B if you want to, but why not be clever since they have names? Cole, before the collision, who's running? Hobbes, Calvin, both, or neither? Both, stuck together or separate before the collision. So I'm going to have this. The mass of Hobbes, the velocity of Hobbes initial, and the mass of Calvin, velocity of Calvin initial. Is that right? Yeah. Wham! They collide. After the collision, stuck together. What kind of a collision is this? Elastic or inelastic? This is an inelastic collision, stuck together. So I'm going to have mass of Hobbes and mass of Calvin V final. How do I get the V final, which is what they want by itself? Okay, so I'm going to get this. V final equals mass Hobbes, V Hobbes initial, plus mass Calvin, V Calvin initial, divided by mass Hobbes plus mass Calvin. If you think about it, here's what we're really saying. All of their momentum combined, but their new velocity has to be applied to both of their masses. So I think overall, I think Hobbes is going to slow down. I think Calvin is going to speed up, because I've seen people get tackled from behind, and that's usually what happened. The chaser slows down, the person getting tackled speeds up. Should find that. So if we really quickly crunch the numbers, I'm going to cut corners and not write this out. I'm going to go straight to my calculator, which is really bad, but we will. I need to scroll up here, Mr. Dewick. So I have bracket, mass of Hobbes, 31.8, times velocity of Hobbes, 11, plus mass of Calvin, 25.1, times velocity of Calvin, 8.33, close bracket, divided by bracket, 31.8 plus 25.1. After the collision, did I say 9.8 in my answer key, I hope? Okay. I would probably keep the extra sig fig somewhere because I'm going to use this. In fact, I'll store this on my calculator. Where people are having trouble with is with B, because B is so easy that it's tough. Christy, what does B want me to find? Yeah. On who? Hobbes. What's another word for impulse? Yeah. You know what? I'll write this down. And I'll even put an H for Hobbes. How can I find impulse? Lots of ways. What did I find, Christy, in part A? A final velocity? You know what? The fact that I found that in part A, I think I'm going to try finding impulse using mv final minus mv initial, not force times time. See, I put that together, okay? So I'm going to say maybe it's mass Hobbes v Hobbes final minus mass Hobbes v Hobbes initial. What was the mass of Hobbes? 31.8 times. What was his final velocity? I have it stored on my calculator, so I'm going to use my answer button. 9.822 blah, blah, blah. Minus 31.8 times. What was Hobbes's initial velocity? Christy, my angel. Yep. By the way, did Hobbes slow down or speed up when he hit Calvin? So did he gain momentum or lose momentum? So am I expecting a positive impulse or a negative impulse? Did I get a negative? Oh, heck yeah. Is that going to freak me out? No, that's going to relax me and make me think I probably did this correct. Does the answer say negative 37.45? Now, if Hobbes lost 37.45, what did Calvin gain? So that's how you do C. You could also, if you wanted to, go impulse is another word for change in momentum. How am I going to find change in momentum? MV final minus MV initial. You could walk through exactly what I walked through in part B for Hobbes with Calvin. Or, Oliver, you can say, you know what? Momentum is conserved. If Hobbes lost, Calvin gained. That's the law of conservation of momentum. That's how you can use it with impulse as well. What did D want me to find, Chloe? Oh, you didn't open up to? Okay, fine.
The force.
What did I find in part B and C? Impulse? Hey, is there an equation that has force and impulse in it? There is. It's force times time. I think if I take this number and I divide it by the time, 0.109, there's the force. Negative to Hobbes because it slowed Hobbes down. Positive to Calvin. So really, I would just give the magnitude. Did I say it was 344 newtons? Yeah, there you go. Is that okay, David? And so you'll do something very similar for number 5, but I think in number 5, they're running at each other. So we have some very powerful tools at our disposal. In fact, I've taught you the whole unit. Now, we are going to look at explosions, and I'll even give you the punchline right now. Suppose this was a little tiny bomb or cannonball or something right here. What's its momentum right now? Meant to be stupidly obvious. So after the explosion, what must its momentum be? Still 0. That's an explosion. An explosion, if you want me to give you the physics definition, it's when you start out with a momentum of 0 and end up with a momentum of 0. Now, the only way that works is if one piece goes that way and one piece goes that way, or if one big piece goes that way slow and one small piece goes that way quick, and we'll look at explosions and things like that. Right now, see, I see you Monday. Your test is probably going to be next, not this Wednesday, but a week from Wednesday. Ish. It's a short unit because I don't need to teach you forces. I already did. F equals ma. Hopefully I've drilled that into you so that you always have that at your disposal as well. And much of what I've taught you could be solved using other methods. This is just a much more convenient shortcut. Is that all right? So please use this time. I don't often give you this much time to work on homework. Please use this. You're getting, holy smokes, 40 minutes. This is your chance to get everything caught up and ask me questions. Pick your brain. Okay? I don't want to see anybody on their phones on videos or anything like that.